Hey guys, and welcome to Go Builda TV. This is our last FTC Friday of the off season, so we are super excited to do some season specific, some Freight Frenzy specific content for you today. Here I've got my good old friend the Beeline chassis, and we're going to be doing a lot of prototyping with him today. Manufactured Chaos, hey, it's great to see you here. Hope you guys stick around. Today, unlike usual, we're not going to be doing any giveaways. We've saved all of those for next week, which is, of course, what we're building up to. Monday, Tuesday, and Wednesday, we're going to have a robot in 3 days, robot in 15 hours, where we're going to get a couple of guests in, some FTC alumni who are really well known in the space, and we're going to put together a robot to play the game. So we're going to get all our field stuff set up tomorrow, and we are super excited to bring that content to you guys after kickoff for this season. And just to mention, the goals for that show are to really be able to show you guys some options for prototypes, show you guys how you can play with the game, and show you how parts interact with game elements in some cool ways you can do that. So we won't be doing stuff like releasing CAD or bills of materials for that build. It's just for you guys to be able to draw inspiration and go from there. So here today I've got a Beeline chassis, like I mentioned earlier. It's running on a Go Builda radio system, so with the intention of being super easy to run and super quick for us to get up and running and show you guys some prototyping options. I've also got some cubes and some balls. Now, these are some of the few things we know right now about this game is that we're going to be using these game elements. Now, these are the same elements that teams have been using a couple of years now. Relic Recovery and, not Relic Recovery, Rover Ruckus, the other RR game, used these exact elements, as did Rescue, RES-Q. So, if you're new to FTC, if you're a newer team, feel free to go Google those two games, Google some high scores and world records, because those will probably have some really good examples of how people have worked with these elements before. Now, both of these elements were also used individually in their own games. These balls were used in Cascade Effect, and these blocks were used in Block Party. So they are definitely something that we've seen before, but they're pretty fun game elements to play with, I think. Yep, Block Party, so those are all great resources, and that kind of goes back to some old FTC too. You'll see, if you Google Block Party games, you're going to see some old looking robots that are primarily like the world winners those years used claws and had very simple robots compared to some of today's robots. So I'm going to go ahead and get this guy up and running, all hooked up. It is running our new motor controllers and a transmitter and receiver. So it's all very, very simple. Should be pretty plug and play. Well, that's okay. We'll figure out what's going on there. Probably just something that was not plugged in correctly. Okay. So these are a Beeline chassis, and it probably isn't a chassis that many of you guys are going to be get up and running for this competition. Many of you are probably going to be using the Strafer, which you can see over in that corner, as it's mechanism driven. Now, we don't know what this field terrain is going to look like. It might have some cool elements that you may have to drive over and stuff like that. Let's see here. Yep. So this is all set up on a radio system with a tank steering, because I like it, and we've got a Go Builda lanyard. So if you guys are going to a kickoff event, if it's sponsored by Go Builda, you'll probably get one of these. If your event isn't sponsored by Go Builda, make sure to let your affiliate partner know, hey, next year you guys should fill out the event form, and Go Builda will get you some cool prizes and giveaways and stuff like that. So if we don't get you this year, we're hoping that we can capture a lot of you guys next year. So with this, we're going to grab this, we're going to grab some of these elements, we have some more over there, and we're just going to move over to our field and drive around a little bit. Okay, I bet we probably have audio over here on the main camera if I had to guess. Okay, here, I'll fix that real quick, hopefully. That's my bad, actually. Okay, so... Okay, you guys should be able to hear me now? Maybe? Yes. That does seem to work. It's just going to only come through one ear. There we go. Okay, that should be back now. Okay, that's definitely my fault there. And we'll drop it back over here. Okay, there we go. All right, sorry you guys. We're back this season. We had a pretty long break, so always working out some bugs like that. So thank you guys for bearing with us and working through some of the issues and letting us know. That part of working with us in the chat is really helpful. So now we've done what I think is kind of the primary and the first step in prototyping a solution to a game element, and that is prototyping, and that is specifically finding out your issue, which in this case is controlling the balls and making it so that they can go to precise locations and kind of stay where we want them. So that's the issue that we're going to be trying to solve today. And this is the hope for this stream is to kind of give you an idea of what I like to use as my design process and what we're hopefully going to be following fairly closely next week when we stream for Robot in 3 days. We may also be able to use this prototype once we see the actual game and have some examples of how we can do that. So we'll move back over to our build station, and we've got some elements over here. The next thing we want to look at is the size of the elements that we're going to be intaking and figure out how are we going to do that very effectively. We're going to go ahead and unplug this so it's a little safer to work on. And we've got two different size intake, or two different size elements that we're hoping to intake. And that is something that can lead to some difficulties. This is going to look like it's about 2.8 inches or just about 72 millimeters. These cubes are looking like just about 50 mil or just about 2 inches. So you've got two different size elements, so whatever you use to control both has to have some compliance. Okay, same audio is playing twice. Well, that's too bad.
I just muted primary because it
Okay.
was moving as well as that one. So
Okay.
see if that
Well, hopefully that helps. Thank you, guys. And let us know if it goes away now or if it's still there. So we've got our elements and we know the size. And depending on what we have to do with these elements, we can use that size to our advantage. So we'll talk about that more a little bit later, talking about how we can use the different sizes of these elements to interact with them in different ways. But for now, we're just going to look at solving that as a challenge. So we've got our objective. We have the controllability of these elements, making it so they don't just roll away from us when we're driving them around. And we also need to solve the issue of being different sized. Now, the primary way we do that is with compliant wheels. We have a game element that we're intaking, that we're working with, that is rigid. It's not compliant, and we've got a chassis or the rest of our robot that isn't compliant in this build. So we want to have our wheels be compliant. You can solve that in different ways by, say, if you're intaking some soft, squishy balls, you may not need a compliant mechanism or a compliant wheel. Or if you'd rather use a solid wheel, you can have a compliant mechanism. So something that may be spring operated where you can adjust its height to the ground with kind of variably with those elements. I grabbed the 96 millimeter gecko wheels. They are the largest size of gecko wheel that we currently offer. We have some more on the way, but they aren't larger than 96 millimeters. So that's going to give us the most amount of squish and the most variation in the size of intake of element that we can intake. something that we can do to kind of work out if this is going to be enough is measure this wheel while it is expanded, and then measure it again while it's contracted to see how much squish we can get. So when fully out, we've got 96 millimeters. And then when we can fully contract this wheel, we'll kind of abuse my calipers just a little bit here. We're kind of look like we're in the 55 millimeter range. So we'll call that 56 for some easy math. We know we're going to be able to move about 40 millimeters in the diameter, which turns into 20 millimeters in the radius. Now, if we looked at this earlier, we had about a 70 millimeter ball and a 50 millimeter cube. So it's going to be a little close, but I think we'll be able to work with both of these elements with just one wheel size, as long as we're fairly sure that we have the distance from the ground pretty precise. Now, this brings into some discussion about how we build with for non-GoBuilder components with GoBuilder parts, but we'll talk about that in just a minute. I think these are going to be our best bet. That will allow us to not make a compliant mechanism, which tends to be a lot more complex. And the biggest enemy that, in my opinion, you face with prototyping is complexity. You want to make something that is as simple as possible and achieves your goal so that you can either move on and prototype a next mechanism or solve out and compare this to other prototypes. So let's look at how you build with non-GoBuilder parts in GoBuilder. A lot of GoBuilder components are designed around the pattern and having things that are very pattern-based dimensions, very correct dimensions, and that makes it, when you're building for GoBuilder size elements, pretty easy to get the correct wheel spacing and stuff like that. But when you start working with objects that aren't in the GoBuilder ecosystem, which you will for FTC, you start looking at ways to build a lot of variety into the sizing of your mechanisms. And there are a few primary ways we do that. One of that, both of them involve kind of extrusion styles. One being Go Rail, where you have a slide and lock system. You can really precisely choose the distance between two wheels, say, to grab an element. And the other one being something like Go Tube and a clamping mount, where you can really clamp onto something like Go Tube or Go Rail and slide that along the surface. So we have a few different ways to go about doing that. And today we're going to primarily try it without some of that variety built in first, just because we can build that a little quicker and a little simpler. Now, the simplest way to do this is going to be having a shaft go across the front of this intake right here with 3 wheels. Let's see here. Well, I don't think 3 wheels are gonna work very well for us today. We'll get kind of a closer up view for you here. We want some gecko wheels definitely here. I think with 3 wheels, we probably are going to want 4 or 5 at this point, just in case, just to get this wheel spacing a little closer so that we can interact with the elements more consistently. That is something that's very, very important when you're building final mechanisms, is the consistency of being able to intake stuff. So we have somewhere around 5 different wheels here. I think that looks like a really great number. So we're going to want to build a shaft that goes across the top of this intake right here. The simplest way to do that would be some pillow blocks, some bottom tapped pillow blocks, and a shaft. That would go across the width of the chassis. So let's grab a 300 millimeter shaft just to act as kind of a stand-in. And if we set that 24 millimeters above the surface, we can figure out our wheel size. We can figure out how far away from the ground those are going to be. So, thankfully, from a math perspective, these are both 96 millimeters. Our roller wheels and our gecko wheels. So we can almost ignore that as a factor. So we just need to figure out the distance between these 2 shafts. So we know that's going to be 48 millimeters on normal GoBuilder spacing. You're going to move the second shaft up 48 millimeters if you use some bottom tapped pillow blocks. That's 24 millimeters for the channel and 24 millimeters from the pillow block. 48 millimeters happens to be really darn close to the size of this game element. I swear I didn't actually plan that out. That was definitely lucky. So we'll grab some 8 millimeter pillow blocks. We can bolt these to the sides of this chassis, and we can install a shaft that's going to go the length. We'll worry about powering it next, but for now I think that's a pretty darn good path forward. So we'll set our wheels aside. We've got our 2 pillow blocks, we've got their locations, and we have got this ready to go. So I'm going to grab some screws. I'd say 8mm screws are going to be the best here. And I've already got my tools set up right here. Okay. So this is the first step. Looks like actually, because I've got some standoffs here, this is a cool trick. We've got some standoffs in the very end, the final hole of the channel. I can actually show that to you here with our fancy close-up camera, if it will focus. Yeah, so we've got some standoffs here on the very final hole of this channel, and that gives you a lot of extra strength and gives you some extra durability if you are in a situation where you may contact other robots with that piece of channel. That's great in a lot of cases, but it makes putting a screw in right here just a little bit harder. So we're going to have to use a ball end hex key instead of our standard flat end hex key. Our old-time viewers will know this as a topic of conversation I like to mention a lot, but if you can use flat end hex keys, you can transfer more torque through them, and they are, in my opinion, nicer. Today I've actually got one of our nice Wera T-handles, which has a, it's got a retention ball on the end, so makes it even easier to install a screw in applications like this. I don't have to worry about holding the screw. I can just stick it in and spin our hex key. And the other thing that I like to do when I'm tightening and working in applications like this is to tighten one screw at a time. So that way I can make sure to get the second screw in place and correct before. This fit is too good, I guess. Whew, gotta get that out of that screw. That's funny. There we go. Okay, and now that we've got most of that done, I'm going to use a short side of the Allen key, put a lot of torque on that, and torque down the bottom one. So you kind of screw in a lot of screws in 2 steps, where you seat both parts, seat both screws in both parts, and then torque them down to a reasonable spec. We'll go back to using our ball end to get this one inserted correctly. And if I can hold on to it, we'll get this piece bolted in place, and the next step is probably going to be putting some hubs on these wheels. For this, I'm actually going to use a little 12-volt DeWalt impact. It's going to make it a lot quicker. This also has a torque limiting feature, which is really nice. This can mean I'm not going to put an excess, really high amount of torque into that system, which I wouldn't want to do because I want to be able to get those screws back off. Especially because I'm going into plastic, that would be suboptimal. So I've got Sonic hubs here. Now Sonic hubs and Gecko wheels are great and a little harder to use. Gecko wheels were designed kind of with 2 hubs in mind, the Sonic hub and the Hyper hub. So one side of the hub has a 12mm drop, the other side has an 8mm drop. Now the 12 is great for a Hyper. It allows just the screws of the Hyper hub to stick out and makes it really nice and easy to work with. The 8 side is sized correctly for a Sonic hub, so that's going to get you the best approach when you're using a Sonic hub, because you can fully seat it inside the wheel. The other thing we've got right here are some pattern spacers. I like using these under screw heads when I'm using plastic parts. The other thing you can use are washers, but that's going to take just a little bit more time today, and we're hoping to build this really quick. So here I've got some 4mm pattern spacers. I've got 4mm of core, and I've got 8mm of hub. So ideally, I'm going to want a 12mm screw. Perfect. Just going to seal the whole bin. Now, because the Sonic hub recesses completely inside the core of the Gecko wheel, we need to install the shaft, the Sonic hub onto the shaft before we install the hub. This, in this application, is actually probably going to be a little tricky. I think the easiest thing to do here is actually going to be to take off one of those pillow blocks. That way I can put the whole shaft together, install it in the correct place, and then install the second pillow block as a piece of support. So that's what I'm going to do. I'll also take a minute while I'm doing this, undoing the work I've already done, of course, to mention what we're doing here. So today we're working on some prototypes. If you haven't figured out by now and joined after the start of the stream, we're working on a prototype intake for the Fright Frenzy elements, at least what we know. The other thing that we know that we haven't talked about today yet is that we probably are going to be modifying some of the cubes at least in some way. So it's very possible they'll say, oh man, you got to strap 12 of these things together and interact with one massive element. Now would be a good time to mention that we don't have any idea what's going on with this game. We find out tomorrow at noon Central, or noon Eastern, just like you guys. So what we do today may not be important at all, and we may find out that tomorrow, hey, all that prototyping you guys did, just throw it out the window, in which case we'll be just fine. One thing we'll grab here is a couple of collars. We're going to use those to constrain the shaft once we have the other pillow block on. Boom. So the first thing that's going to get installed in this shaft is a pillow block. Then we'll install our first Sonic hub. So we'll say about there looks pretty good to me. We'll go ahead and tighten this down. And with it being fully seated inside of the Gecko wheel core, we don't have access to these pinch bolts later. So I do want to get these not crazy tight, not Josh tight as we say here at GoBuilda, because we have somebody who tightens stuff a lot, but fairly tight, just so that it stays in place and we don't have to worry about that screw coming loose. If this was a competition robot, I would probably think about Loctiting that screw right now, just to make sure it's not going anywhere and that we'll be going good. Baron brought up a great thing, sorry, Beebs in the chat mentioned, when does our Robot in 3 Days start? Our Robot in 3 Days starts on Monday at 4 Central, so 5 Eastern, and we're going to go till 9. We actually modified the hours this year. We know a lot of you guys are in real life school this year instead of virtual school, so we know a lot of you joined during school hours last year, and we love to see you, but this year we want to make it so everybody can watch. So you may miss the very start of it. If you're in mountain time, it's a little more unfortunate, but that should give you a lot more better chance to catch us live and talk to us in the chat and stuff like that. Beebs also mentioned standoffs and quad block mounts are great for keeping your channel square and not bent in or out. Definitely, those are both really key tools, especially the 43mm standoff. That's something that I think every team who uses GoBuilda should have in their arsenal. It's so key. So we've got the first wheel installed on our shaft. We're going to go through, just make sure it's in the right place. I think that's in a pretty good place. Could we have moved it over a little bit? I think we could have, but that's okay. And what I'm going to do now is kind of place the rest of these on the shaft where I think I'm going to want them, just to kind of size out our spacing here. It's not scientific at all, but I think that looks pretty good. We're going to maybe move this guy out a little bit, tighten it down so it's in the right place, and we'll go ahead and install our next wheel. I pronounce it Zeb. Zeb? I guess that be Zeebed. Any hot takes for the challenge this year? I'm really interested to see what you guys have in the chat. I don't have a whole lot of hot takes for this challenge, really. I'm interested to see. I really hope they do something cool and unique with these elements. I know in my FTC career, I've seen them used quite a few times. So that will be, I think, exciting to see what some new and innovative things they do, especially with modifying. I think they confirmed they were modifying the blocks, doing something with the blocks for sure. So I'm excited about that. That seems like it's going to be fun. I'm also just overall pretty excited to get back at some in real life competitions, hopefully. I know I don't want to jinx it, but I think we might see some more, at least hybrid competitions. Might be climb. I do want to see another climbing game. I liked climbing games. I have this weird opinion of games. These build streams get a little ranty in the middle, and I'm sorry for that. But I guess that's what you guys tune in for, so it's probably fine. I like games with really intense end games, and I hate them because on the one hand, it's really engaging. Like, oh man, that team might knock over their stack at the very end in the last 5 seconds. But the downside is exactly that. Like, you might be ahead all of the game, and then, oh man, I didn't mean to do that, and then you knock over your stack and you lose. And the same thing with something like climbing. You know, you might do great in driver controlled, and then at the very end, whoops, my robot fell off the hanger and I lost state finals. That's never happened to any teams I've been mentoring though. Nope. So they're very fun. They're great from an audience engagement standpoint, but they can be a little ruthless to teams who are working with those elements. I think that's some pretty good spacing, and we can get a pretty good idea of how this is going to grab these cubes, which I think is pretty solid. And it looks like we're going to have enough compliance to pull these wheels in. These wheels, excuse me, these balls. I dropped the Sonic Hub. That was silly of me. I would love to see a climb come back. Those were always fun. I do think climbs are always fun. I always think back to, there's a video circulating online of the first quad hang in Block Party. So Block Party had a 4 robot wide bar in the center of the field, and you had 4 robots that all hung on to the same bar, and people went wild. It was great. Just so fun to see that. And it was also cool. You know, I'm from Iowa. I think they're a great region. Shout out to all those teams. It was cool to see them like really have a cool moment like that. I wonder if they will add a sticker that we have to use the camera to see. Oh, on the cubes. That's a cool idea. I could see something like that, kind of like the stones, I guess, in last year's game. Let's go Iowa, says Manufactured Chaos. I agree. Though, at this point, I don't know that many Iowa teams anymore. It's kind of sad. I need to get to some more Iowa events this season. I did a lot with Oklahoma last year, so that was fun. I got to volunteer. They had a couple in-person events that I went and I refereed at. The state championship I actually refereed and judged. So it was a busy. I judged the weekend before, then went and refed. So that was fun. It was cool to see all those teams and talk to them and learn about their robots, and the next week be like, oh, that's how that works in person. That's pretty cool. I do miss my Iowa teams, though, especially Thor. I love you guys. I love a lot of teams. Love to have you attend events in Iowa. That's great. Double duty, because that means I get to visit my family there too. So hopefully I'll get to some league meets this year, maybe get state championships again. I have TW Zumbas, says OMG, it's Go Builda. Hey, good to see you. Happy that you're joining us for the stream. Definitely, if you can, join us next week for Robot in 3 days. I know I keep saying it. I'm just so pumped. It's going to be awesome. These are a pretty nice press fit, I'm going to say. So it's a little more difficult to get them to screw in. You get a little more resistance the whole way. So that's why it's taken me a little longer than usual, as well as I'm being a little chatty today. But I'm excited. Kickoff is tomorrow. It's the last day of the off season. How much does it cost to ship Ethan to your state championship? Shoot us an email to marketing@gobuilda.com. Let them know how much you want me to be there, and we'll see if we can convince them. I think together we can do it. Together we can get to a bunch of state championships this year. Yes, they said you can use your old cubes and modify them. So maybe a sticker. Yeah, sticker makes sense for that. I think think it'd be cool to stick a bunch together. I mentioned that as a joke at the beginning, but I think that'd be neat. I think that I saw that originally on the FTC Discord, discord.gg/first-tech-challenge if you're not over there. It's a really fun community. It's changed a lot in the years I've been there, but I think it's in a really fun place today. And I'm there a bunch, so feel free to ping me and ask me questions. You can also direct message me on Discord. I'm Ethan D. My last name is Doak. Ethan D. Hashtag 0001. 3 zeros and then a 1. You can call me Zom, as in zombie. I like that. Let's see here. I think that our viewers always have great Twitch names. I always am like, oh, that's a fun Twitch name every time I call out a giveaway winner or something. Okay. Let's get this on. I think this might be, let's see, how are we on time? We'll try to get one more wheel installed. One fun trick that I like to do for aligning parts in GoBuilda, we'll actually go back to some tech tips today, is a 3mm hex driver fits pretty well through an M4 threaded hole. So if you're aligning 4mm through parts with 4mm threaded parts, it can be really useful to use that as kind of an indicator to align stuff. There we go. So we got that in. PA Champs is cool. Plan to visit us. I've wanted to make it out to a Pennsylvania Championships for a long time. That's honestly one of my bucket list states. You'll have like some great teams. You always have great teams over in PA. Brainstem and Out of the Box normally goes there, and Cruise Control, and there are so many good teams that I feel bad naming anybody, because like there's a list, you know. They have people who are just awesome and really inspirational. Even in my FTC career, there are some like PA teams who are still around. A lot of those eastern states are that way. Massachusetts, you know, you still have brainstormers who've been amazing in FTC for, I don't know, close to 10 years probably now. A long time. So we've got 2 more wheels here. We're just going to do one more installed. Get our last Sonic. At the end of the robot in 3 days, we'll do a practice match for Fright Frenzy. We hope to. That's definitely on our list of things to do. The last day ends up being a lot of testing and refining, and it's a third of the time that we spend, but I think in competition in FTC, you spend a lot more than a third of the time on refinement. Prototyping and building concepts is a really important part of the first year. Or, excuse me, not the first year. The first part of the season, but then you get into the refining and the execution of the design that becomes really important. Why not using a strafer? That's a great question. Primarily because I wanted this to be really quick and easy to set up, and a tank drive is really quick and easy to set up. We do have the strafer over there. It'll definitely be running for Monday, but today we decided, hey, let's go simple, let's go quick and easy. So we decided to go with the B-Line. Plus, I like the B-Line. I have an affinity for it. It's not the most popular chassis, but I love 6-wheel drives. I've always loved 6-wheel drives. I was really excited last year because we got some really cool competitive 6-wheel drives. I especially show up to MTI, and we got to see some like really cool defense. If you haven't seen any MTI matches, I would say go back and watch them. I think they're totally worth it. They were a lot of fun, especially seeing teams like Beachbots and Wolfpack. I think I could do a whole show just being excited about Wolfpack Machina. They're an awesome team. I judged at MTI. We gave them did we give them Hardware Mastery? Oh no, we gave them one of the Robot Design Awards. They're an amazing team. They really blew me away. Let's see here, there's my tools. So we'll go ahead and we've got our roller. It's not spaced the most evenly, so that's okay though. We're just trying to make something really quick. We're going to install this pillow block. We're going to try to install the pillow block. And before I forget, we also need to add this collar. Now these two collars are going to play a really key role in constraining the shaft and also allowing us to move that shaft left and right if we're ever in a situation where we want to scooch it just a little bit. So we'll get the first screw most of the way in, maybe even a little snug, and then we'll go ahead and screw in the second. Now this is, I'm glad that we did end up uninstalling this pillow block and putting it back on, because when you're working with screws and shafts, you generally want to install the shaft before you tighten everything down. That gives you the best chance of keeping those aligned, and even though tolerances on Good Build stuff are really good, you still get a little bit of wobble in a screw, and a little bit of misalignment is possible if you don't make sure to tighten everything in the right order. So generally, if you're working with pillow blocks, try to tighten the screws after you install the shaft. So we've got our pillow blocks installed, we've got our shaft roller. We're going to go ahead and tighten down this second collar. You can see that these two collars, I'll actually show you with this up close camera. You can see here that we've got this collar is on the inside of this pillow block. The bearing is on the inside of this pillow block. And we've got another collar over here. Now these are opposing one another, so this shaft is fully constrained, and you can see spins nice and freely. So what we're going to test next is that distance from the ground. So this is a ball, this is our larger object, so if we just want to push that over, that actually seems to work pretty well. Now you can notice we actually have a little bit of rock that's from our dropped center on this chassis, and it looks like if we kind of roll up to this cube, it pulls that in pretty well as well. So this is a great prototype. Something like this, you could totally grab a motor and set it up to power it, or grab something like a drill. Especially when you're working with Rex shaft, it's really convenient to use a drill to power a shaft, do some really quick and easy prototyping. But I think we've probably got enough time to really quickly strap a motor on this and see how it goes. Now, we're going to prioritize the speed at which we can do this prototyping more than we prioritize the cleanliness of this prototype. So we're going to do something really quick. We're probably not even going to make this fit in the 18 inches. You know, we don't have a whole lot of time, so we're going to take this wheel off, make it a little easier to access that shaft. This front wheel is just on a Sonic hub, so it's easy to come back off. And we want to make sure we keep an eye on that shim. Make sure it's always around where we can see it. Let's see, I want to catch up on the chat. Hey, Mechanical Meltdown, it's nice to see you guys. Hey, 19368, good to see you. Did that happen last time we used, that did happen last time we used these, so maybe. I'm not quite sure what you're talking about there. I'm sure it was a reply to something that I said. I missed it in the chat, and it made total sense in context. Let's see, what would be the easiest way to power this? The easiest way to power this is probably just going to be a coupler and a motor. It's not the best way, but that's okay. That gives us a chance to do some prototyping. We can even hang on to this motor. This is an 80 mil shaft. I think it's going to give us a little more clearance. Yeah, I think that's a pretty nice idea. Let's see if I've got the coupler I'm going to need. Looks like I've got a 60-day Rex coupler. That's going to be easier. So I'll grab a 5203. Excuse me, not an 03. I'll grab an 02. We'll go classic. Now, there's a lot of thought that can be put into the speed that you run an intake. And that's because you want to be able to run your intake at a speed that can pull in something like a ball faster than you can drive away from it. So generally, what you'd be talking about there is tangent speed. So the tangent speed of the intake wheel compared to the tangent speed of your drivetrain. Let's say your drivetrain has a faster tangent speed than your wheels. In that case, if this ball is sitting here in your intake, it's idling, it's spinning, and you drive away at full speed, your robot can drive away from that ball faster than your intake can pull it in. So you a lot of times want to be at least as fast as you want to have those tangent speeds at least match. Ideally, the intake is faster. And a lot of times, fast intakes end up being better anyway. So we're going to go with a 13.7 to 1. That's going to be a 435 RPM compared to our chassis, which is going to run on 312 RPM. we can just compare RPM because we're using the same size wheels. They're both 96. And yeah, so there's our collar. 123 says belt the motor. If we had a little more time today, I totally would, but I know that at least some people want to leave at 5. Boo, I know, blah, blah, blah. So we'll go ahead and do this the quick way. So we'll end up holding onto this motor, we'll run it, and see how that goes. I believe I've got a power switch over here. I think it's in this bin right here. It's in one of these bins. Oh man. Maybe it's not. Okay, that's fine. We'll go ahead and, well, there's a 6-volt battery. Okay. That's okay. Oh, I bet it is in that bin. Yep, I put it in my control systems bin. You know, that was smart of me. If only I thought to look there, you know. So, this is a little power switch I made up. It's actually got an XT30 input and bullets as an output. It's pretty useful. I'm going to grab the battery. Oh, I can't set the chassis up on that side because it's got an intake now. Okay, so we've got our 12-volt battery. We've got our fancy switch. And we're just going to do this the quick way. Now, right now, this motor isn't constrained at all. That's going to be some terrible practice if you were actually going to build a robot, but for prototyping, stuff like this can be good because it means you can really quickly test out an idea and not spend extra time. So we're going to start with the blocks. I think they're going to be the easiest, and I actually think we should reorient ourselves so we can get you guys a nice close-up look. Instead of that, I'm just going to move the little camera. Okay. This also points to a really sweet thing you can do in prototyping, which is take videos. Most cameras nowadays, most phones nowadays, have some sweet slow motion cameras. So you can get to like 360 or 128 frames per second. So we've got our intake, it spins pretty nice. Maybe a little too fast. That was pretty aggressive, but that's kind of what you want to learn when you're prototyping. Ooh, so that's a problem I didn't expect. Huh. I really never would have guessed that would have happened. So that's interesting. You can't see that very great. Let's try that again. Huh. Well, let's try to give ourselves a little bit more room under that intake. We also made a pretty good shooter, it looks like. So we definitely would want to, if this was a real competition robot, shield this area right here. And really, if this was a robot, you're going to have a mechanism back here behind this intake that you're going to be intaking up into. So that is something that you want to look at, but this is a cool prototype. Now what I want to do is move over to the field real quick and see if this behavior with the balls happens when you have a higher coefficient of friction between the ball and the ground. Here we're on a wood table and there may be less coefficient of friction than this ball and the tile. So it may grip the tile better and it may want to compress this wheel, it may want to compress the ball under the wheel a little bit better. So we're actually going to move over there. Oh, as long as I can keep my camera standing up. And we're going to run our prototype. Now this was a pretty quick and dirty prototype. That also, part of that means I'm missing a wheel, so we're not quite the perfect deck height, but we'll go ahead and move over there. We've got a couple elements. We'll grab some more from our cardboard box. Oh, we've actually got some over here. Okay, so we'll test the block again. We weren't on the correct field surface before, so we want to make sure that works. This also highlights some of the nice parts of having variable control of the speed in your prototyping. So using something like a rev hub is nice because you can have control over how fast it's spinning. So we'll go ahead and turn this on. And we'll push the robot. That does pretty well. Now we're going to have to modify it so that it can't flip up into the robot. But depending on how you look at it, maybe that's good. We don't know what this game is, so we may just want to carry blocks and balls around the whole game.
I doubt that's going to happen, but maybe. So we've got those set up. We'll grab our intake, turn it on. Yeah, that's exactly what I thought might happen. So we've got a much higher grip between the field and the ball versus the wood table and the ball. So we get much better grip and it performs way better as an intake. So we still end up shooting some of them. We don't have the most even wheel spacing, so that's probably part of it. Depending on where they get intaked, they have a little more force that may push them up over. The other thing that you'll notice is we're pushing this against a metal surface, and while these balls are in this intake, they're spinning. So you can see they're actually starting to take some marks out of this wheel because it's constantly spinning up against a an aluminum surface with a bunch of holes. So we'll know for Monday. This is some cool notes, and I definitely know more about how to intake these with a horizontal roller style of intake. With that, I think we are pretty good. We'll walk back over here and talk about Monday. So I'll probably keep this prototype together. Gives us a chance to drive this around, probably stick this wheel back on, maybe we'll add a belt, like it was mentioned in the chat. And we will prototype this out with the actual game on Monday. We are crazy excited to do Robot in 3 days, and I'm really excited to be able to see some people who haven't seen an FTC for a little while, so I think this is going to be a whole lot of fun. We really hope you join us. We're super happy that you joined us today and watched this prototyping preview episode of Go Build a TV. And we hope you stick around for the season. After Robot in 3 days, we've got some awesome new parts, some intake parts, some general robot parts, and maybe even some linear motion parts that we're going to be releasing. So we are super excited, and we hope you guys join us next time. See ya!